code. Yeah, so when we are doing problems using this, we still use the same exact equation, the three equations that we derived, the same exact kinematic equations that we have. The only thing is, last time when we were looking at horizontal motion, we looked at x as our positive direction, and here in this case we are looking at y as our positive direction. Now this problem actually is based on a real incident. 1993, a person called Dave Munday went over the Canadian edge of Niagara Falls in a steel ball equipped with an air hole and then fell 48 meters to the water. Now, assume his initial velocity was 0 and neglect the effect of the air on the ball during the fall. How long did Monday fall to reach the water surface? And the second part, what was Monday's velocity as he reached the water surface? Now, there are a couple of magic words in this section as well. Remember that last time the word stop or initial, starting from rest, those are interesting or the important words. And here also we have the word fell. If you see that, falling means starting from 0 velocity. Now I am going to do this problem on the paper and you guys can write down the information, and I am going to set it on the tables. Sample problem, and I have the table. I know that you can't see my paper very well yet, but this is the Niagara Fall. Just a little picture right next to it. This is my positive direction. Up is my positive direction. So everything happens in the downward direction in this case. There is a displacement 48 meters. It is in the downward direction. Therefore, I take it as negative 48. Give me a second. I will write this down and then stop sharing the video. All right. So this is my table. Initial velocity. I know you guys are like, having fun, laughing and all. That's great. But at the same time, I would like you to, if you know the material, take over and complete the problem and send me the answer. How about that? So initial velocity. Now you see that the picture over here, it shows that this is the baseline and this is the origin, and up is positive direction and the water is falling downward. So the displacement of the steel ball is 48 meters. But as you can see, the measurements are done below the origin. Therefore, I have taken it as negative 48. So let me write down the information on the table. Delta y is negative 48. V final, I don't know. V initial is 0 because the ball fell. And then AY is negative 9.8 meter per second square. You might ask me, how comes it's negative? Because it's going down and the acceleration also is pointed down. That's true. But I took the displacement as negative and I am taking the acceleration as negative with respect to the direction I picked as my positive direction. And I'm not going to change this, but there are students who actually can change this alternatively depending on the problem, and they are most welcome to do whatever they want, because as I am teaching 40 students in the semester, I don't want to go back and forth and confuse the students who have not taken physics yet. Now this is what we have, and the problem asked us to find the time. What equation do you pick? All right, the chat box is open. What equation do you pick? First equation, the second, or the third? Quick chat directed to me. What equation do you want to pick to find the time? Equation 1 or 2 or 3? There you go. Which equation? Yep. Not enough answers. I have 23 students in the class today. I have 4 answers, 5 answers. Just you can call it first equation, second equation, or the third equation. That's easier. And my plan or the aim is to find time. Okay, I got 10 responses. 12. Mhm. The second equation where we discuss the displacement. Yes. So let's go with that. Second equation actually has delta x equals, but since we are looking at y direction, I am rewriting it as delta y, v initial t plus 1 half a t square. Now delta y is negative 48. As you can see, initial velocity is 0, and then the time doesn't really matter. 1 half and negative 9.8 and t square. So you have negative 48 equals negative 4.9 t square. Negative cancels out. You get t square equals 48 divided by 4.9. And I think I saw one student sending me the final answer. Let me go back and check. 3.13. 3.13 seconds. If that is correct, give me a thumbs up. Is that what you guys got? All right. Three point 13 seconds. Anything that you don't follow, you have the chat box, you can talk. Or you can unmute and talk. And then the second part of the question, let me go back again, was asking what was Monday's velocity as he reached the water surface? That's the second part of the question. What was the velocity at the impact? Meaning we are looking for V final. We are looking for V final. Now, again, last time I got 15 responses. Which equation do we use? First one, the second one, or the third one? 5 answers. Mm-hmm. Mm-hmm. Well, don't forget, first one has 2 forms, one with the integral, the other without the integral. Do we want to use the integral here? No integral. No integral. We don't want to use an integral here because we have a constant 9.8 meter per second square. Very good. So 20 responses at this point. First equation. Everybody agrees with the first equation. So let's go with that. V final equals V initial plus AT. Now V final equals V initial is 0, negative 9.8, 3.13. And the final velocity is, what's the answer? Did anyone send me the answer yet? No. Negative 30.7. Thank you. Negative 30.7 meter per second. Why negative? Because the velocity at the impact, here's the water, water level down below. And at the time of impact, the arrow is pointed in the downward direction, or the velocity is pointed in the downward direction. That is why we have a negative sign here. So there you have the magnitude of the velocity at the time of impact. In other words, that's called the same as the speed. You can take the positive value and then give the final answer as 30.7 meter per second. That is the magnitude of the impact. And the
Can you just explain one more time how you got negative 9.8 for the acceleration and not just 9.8?
because I go back here, I said that I pick plus as my positive direction. With respect to this direction, acceleration is negative 9.8. Now, as I said, if you are comfortable switching the direction depending on the problem, you can do that. But when it comes to projectile motion, it is easier to stick to one, meaning go up, use AG equals to negative 9.8. So in this problem, clearly the ball is falling down, right? So I still take up as my positive direction. And with respect to the positive direction, the displacement I took as negative 48. Right? Say that someone is taking down as their positive direction, that would give them positive 9.8 as their acceleration. And then this value also will become positive 48 for that person. And they also will end up with the same value for the time as 3.13. And final velocity, they will end up with a positive 30.7 because they took down as their positive direction. Is that clear, Lindsay?
Yeah, that makes sense.
Yeah, I mean, you can do this problem again, taking down as your positive direction. You will have the same exact 3.13 without any sign change. And then here you will end up with a positive 30.7. Okay. Now here we go, another problem. So as I said, the students who are familiar with this physics, you can just go on and complete the problem. Other students, let's work together slowly and then getting the tables ready and go from there. Sample problem number 2. So get the information and put it into the table. So here we have a baseball pitcher and I still take up as my positive direction. So right alongside of the table, I put that. So I mark my positive direction so people won't get confused. So initial speed, let's do this together. On the chart, we initial 12 meter per second. How long does the ball take to reach the maximum height? All right. So that's the problem. The only value that is given to us is the 12 meter per second. Now, how long does the ball take to reach the maximum height? Now, what happens at the maximum height? Can someone tell me? Not someone. Can everyone tell me? Or text, like send a text on the chat box. What is the velocity of the ball? Y velocity of the ball at the top or at the maximum height, maximum point? Very good. At the maximum point, okay? I'm asking at the maximum point. At the maximum point, what is the speed? What is the velocity? Not enough answers. I have about 8. Just you can just throw a like your pen, like toss your pen up and then see how far it go. And then right at the maximum point, what is its speed? Why is it coming back down? Not enough. I only have 1/3 of the class giving me an answer. What is the final velocity if you just take from the beginning to all the way to the top? I don't know, some of you may be thinking that, maybe you are thinking that you know it and shouldn't really, give it a shot to like contribute. But that is not right because it just keeps me waiting. So the final velocity, the ball, when it reaches the top, is 0. It's momentarily, it stops and then starts coming down, right? So that's what we have here. So we start from a point, initial velocity is given, and then it reaches to the maximum point. We call it maximum because it is not going beyond that point. Why isn't it going beyond that point? Because it stops at that point. Then after that, it starts coming back down. By the way, Thursday quiz is going to be on this. Thursday quiz is going to be on this, and it is going to be an individual quiz, unlike the last time. Now, final velocity or the velocity at the top equals to 0. Initial velocity is given. Now I am going to mark this as 0 and I'm going to call this point A, the point over there B, and on the table I say the ball going from A to B, and this is my graph. The table. This is my table. And in order to find the time, let me see, let me go back again. The first part of the question is, how long does the ball take to reach the maximum height? The second part is asking, what is the ball's maximum height? So I'm going to do both at once. So we have initial velocity, final velocity, acceleration, and we need to find time. What equation do we use? First equation. Thank you, Jed. So we have V final equals V initial plus AT. V final equals to 0, V initial is 12, and negative 9.8 times T. So you get 12 equals to 9.8 T. This is algebra. I can go fast. 12 divided by 9.8 and send me the answer. Kaylan, do you have the time?
The time was 1.22
Correct.
seconds.
Thank you. Yes. 1.22 seconds. So the time is 1.22 seconds, and this is the answer for part A. And then the second part asks us to find the height. What equation to use now? To find the maximum height. The second equation. Thank you, Jack. Delta y equals V initial t plus 1/2 a t square. So you got delta y from A to B. That's where the maximum height is. At point B, it reaches the maximum. So the distance from A to B is what is called as the maximum height. So the initial velocity is 12. The corresponding time is 1.22, 1/2, negative 9.8, and 1.22 square. Send me the answer. I know that some of you already sent me the answer. Thank you. Uh-huh. Watch out on the negative sign. If you don't have the negative sign, you will end up with a wrong answer. And also watch out for the units. Units matter. Without a unit, answer is wrong. So the most popular answer here is 7.35. Thank you guys. 7 point, very easy to work with you. 7.35 meters. So the maximum height is 7.35 meters. In one or two cases, I have 22.17, and that may be because you have forgotten to take the negative into consideration. Instead of having the negative, if you have the positive, maybe the answer is 22.17. Great. So the answer for part B, maximum height equals to 7.35 meters. Perfect. Next, last part. It's okay to round it up, and 7.34, 7.346, 7.35. I will take all answers as correct answers. No worries there. I'm responding to one of the questions on the chat. Now, so let me go back to the slide again. There you have the last part. I usually give like 2 points bonus to whoever does this part. Since I am not in the class, I can't do that now. But let's see how many of you can figure this out and send me the answer. How long does the ball take to reach a point 5 meters above from its release point? I see an answer already. Wow, guys, very good. I have two answers and they are identical. Very good. However, I am looking for not just one time. I am looking for 2 times because the 5 meter happens twice in this journey. All right. Yeah. So one student gave me both times. Good. Very good. So 5 meter. Now, how long does the ball take to reach a point 5 meters above its release point? Now, let me take this over here. So let me redraw the picture. This is now with more information. VI is 12, all the way to the top where you have the final velocity 0. And then you are coming back. Actually, you are coming back along the same path. And we know the maximum height equals to 7.35 meters. Now, where is this 5 meter mark? 5 meter mark is somewhere over here, let's say. This is 5 meter displacement. Now, the 5 meter displacement happens twice, guys. Pay attention to this. It happens twice. So you go up, and then when the ball reaches this point, the displacement is 5 meters. And you call this as time 1. And then it goes all the way to the top and returns and pass the same point. And that time, we call the time corresponding to that part is as time 2, T2. Now with the information that we have, delta y equals to 5 meters, v initial 12 meter per second. Time, you don't know. And then acceleration didn't change, negative 9.8 meter per second square. It is slowing down when an object was tossed. It slows down, reaches the zero and come down, right? So this perfectly explains the negative sign there. Now I am using the second equation. I have actually more than 12 answers. Very good, very good. Delta y, v initial t plus 1/2 at square. Delta y I use as 5 meters. Initial v, 12, and the time I don't know, t, plus 1/2, negative 9.8, and t square. So you get 5, 12t minus 4.9 t square. Another quadratic equation. Algebra. This is algebra, so I'm not going to waste too much time here. You can rearrange the equation 4.9 t square minus 12t plus 5 equals to 0. And either you can feed this to your TI-89 or simply you can use the equation that I gave you. So there should be 2 times corresponding to the travel of the ball. T1, as I see, 0.53 on the chat box. I'm copying from the chat box. 0.53 and then return trip 1.92 seconds. Perfect. So these are the 2 routes, and here you have 2 positive values for the time, and they both make sense. Positive values for time. So here we do not expect only one value for the time because the 5 meter point is passed twice during this journey. The ball goes up and passes the 5 meter point, and it goes all the way to the 7.35, the maximum height. And along the way, again, it passes the 5 meter displacement and come down. So it has 2 corresponding times, T1 and T2, and you have to find both T1 and T2. Any questions? And that's the end of that example. So this one does not have any calculus. It's completely algebra based. I'm going to do a couple of more problems from the textbook. Problem numbers 52 and 53. I know some of you are doing the problems really, really fast. They can look at the problem numbers 51, 52 and 53. Both at once. It gave me the time alert again. In 10 minutes, it'll stop. If we still have more to do, then we will come back. But let's keep on working. Now, problem number 52. A bolt is dropped from a bridge under construction, falling 90 meters to the valley below the bridge. In how much time does it pass through the last 20% of its fall? What is its speed when it begins that last 20% of its fall and when it reaches the valley beneath the bridge? Those are the 3 parts of the question. A drawing like a bridge would be like a maybe just draw it as a very tall building, and then the height of the building or the height of the bridge is 90 meters. And then 20% of 90 meters. How much is that? And in how much time does it pass through the last 20% of its fall? What is its speed when it begins that last 20% of its fall and when it reaches the ground? You can answer part B first and then part A if you prefer that way. Now, I'm going to ask another question. I am expecting 23 answers on the chat box. I want 23 answers on the chat box. What is the initial velocity of the bolt? What is the initial velocity of the bolt? I got 16 responses. I'm waiting for 7 more. Question again is, what is the initial velocity of the bolt? 18, 19. 4 more. What is the initial velocity of the bolt? Velocity is measured in meter per second. So if you see anything in meters, 100% it is not a velocity. And here's what I would like you to look at. The word dropped. Dropped. Dropped means starting from rest. Another word to remember. These are the magic words that you need to remember or look for. Last problem, we saw the word falling. Falling is also a like an indication that or something that indicates that the initial velocity is 0. And here you have dropped. Dropped also means that the initial velocity is 0. All right, so I'm going to let you guys work on it. And I am going to do the work on the paper. And as I said, I might actually answer part B first and then go to part A. So you don't have to wait for me. You can do your own thing and we can compare the answers. I mean, of course, I will need your help, but you don't need my help, I believe. So this is the bridge, 90 meters tall. Meter is used to measure a length, so don't get it confused with velocity. And then I have the table. Initial velocity 0. Final velocity, well, we have to look at a couple of final velocities, so I'm not going to write anything here. And then the acceleration, as long as I take up as my positive direction, this is negative 9.8 meter per second square. Now, what is 20% of 90? 20% of 90 is 18 meters. So going from A to B, I am covering 72 meters. Going from A to B, I'm covering 72 meters. As I said, I am answering. Oh yeah, I can show the problem again. Problem number 52. I have to bring the camera down and then focus. In how much time does it pass through the last 20% of its fall? And what is its speed when it begins that last 20% of its fall? So there are a number of different ways you can do this. I am going to do it in a way like first I am going to find the time from A to B. So from A to B. And then I'm going to call this point as C. So the delta y from A to B is negative 72 because it's pointed downward, and then the time I don't know. So I am going to use the first equation, the second equation, delta y equals v initial t plus 1/2 a t square. There you have 72. Initial velocity is 0 times t plus 1/2 negative 9.8 and t square. So negative 72 equals negative 4.9 t square. And there t from A to B, I get an answer. Anyone who has the answer, please share that with me. 3.83. Is that right, guys? From A to B? 3.83. I see some nods. And then I'm going to look at the same from A to C. Delta y, v initial t plus 1/2 at square. And then from A to C. Now I'm looking at the motion from A to C. The delta y is now negative 90. V initial 0 times t plus 1/2 negative 9.8 t square. So negative 90, negative 4.9 t square. And using this, I can find the time from A to C. And who has the answer for that?